welcome everybody. Thank you so much for being here. For those who were able to join us last week, thank you so much for your patience on this initial and inaugural tectonic talk. I'm just going to quickly give a little bit of context, but I won't take up too much time. Just to say that for anyone who doesn't know, Chris and I at the top of the new year started a digital magazine called The Rewild, about literally and figuratively getting outside into nature, outside of yourself, and back into your creativity, connection, and inspiration. And we are curious about all the avenues of rewilding work, rewilding self, the body, and our structures and our systems and our culture to just come back to our truest nature. Our most recent issue was called Nature Did It Better. You can probably infer what that's about, but for the sake of being obvious, despite our most sophomoric efforts, time and again, we try to control our environments and control ourselves. And we find again and again that we're met with the wisdom of nature to remind us that it often had a much better answer than we could have concocted. And when we surrender to the wild of nature, we come to a harmonious, collaborative way of understanding our own nature and systems that we don't have to fight against. In that issue, we really came to new awareness about how much we were enjoying these incredible stories and conversations of those we were interviewing and talking to in terms of being collaborators, and we really wanted to share them. And so we thought, wow, we should have a talk, especially in this time of just so much rhetoric and tension. How could we bring some oxygen and good grounding to connective conversations around things that we find really invigorating and interesting? Enter stage left, Vlad. Had a beautiful conversation with Chris, which was the main article for this issue, and kicks off our initial tectonic talk, looking to be the tonic, as it suggests, among otherwise some toxic environments. So why don't you share a little bit about your conversation with Vlad?
Let Vlad get into it, but I'll say that it started with visiting Vlad and his wife Courtney in Philadelphia, and we were watching their son do something, and Vlad said mechanically that is really difficult for models to do, and it kicked off this discussion about Vlad and his work and comparing childhood and babies and how babies go from no intelligence to adult level intelligence and comparing that to AI models. And it just felt like such an enriching and interesting conversation that leads back to threads we will cover later in the discussion, including climate crisis and how can what Vlad is researching in the lab be applied to AI models to make them so much more efficient that we actually don't need as many data centers. So with that, Vlad.
Yeah, thanks, Chris. Man, I just want to qualify one thing you said there. That babies, one thing we learned is that not that babies have come to the world with no intelligence, they actually come with very richly structured intelligence that lets them learn about the world. And I think that's the really amazing part. They just build on what they come to the world on. All right. So with that, I want to start a little historically. Humans have a long history of taking inspiration from nature to solve engineering challenges. For example, Da Vinci famously sought to uncover the secrets of flight by intensely studying the anatomy of birds. And what's remarkable about this process is that it not only helped us solve engineering and societal challenges, but it also helped us uncover some of the fundamental principles of the natural world. And I think that this approach of learning from nature is just as relevant today in the age of AI as it was 500 years ago. Just like Da Vinci, thinking carefully about flight, I want to start today by thinking very carefully about what it means to have intelligence. That is, if we were to build an artificial intelligence system, what do we want it to be able to do? For example, we want to have rapid and unsupervised learning capacities, such that it can learn from just a few or even one example. We want it to have robust logical reasoning and multi-step planning abilities, a sophisticated understanding of the 3D world, and of course, an adaptive motor control system to interact with that world. And any AI system or robotics that has all these qualities would be revolutionary. But like with the existence of birds, many of us actually already have one of these systems in our own homes. So let me show you what I mean by that. So this is a little silly, but this kid is showing reasoning abilities that no AI or robot is currently capable of. He's clearly analyzed the 3D scene and has an intuitive understanding of the physics and how objects move and interact. He has impressive motor control and coordination, and this is almost certainly not something that his parents have taught him to do, but something that he's figured out for himself. And so I'm not exaggerating when I say that there isn't a robot or AI system in existence that can be plopped into that kid's situation and then do this. But in some ways, what this kid did was trivial. Those of us with kids or even pets witness this level of intuitive intelligence every single day. And so if we want to understand how to develop better artificial intelligence, we should start by understanding how intelligence develops in us. And so the title of my talk is The Ultimate Learning Machines: How Insights from Children Can Lead to the Next Generation of Artificial Intelligence. And before I dive in, I want to take a step back and just introduce myself a little bit more. So I'm a cognitive neuroscientist at Temple University here in Philadelphia. And broadly, what that means is that I'm interested in understanding how the brain gives rise to the mind. Basically, how does the brain support intelligence? And ultimately, what is needed for intelligence to arise, either over human development, over childhood, or maybe even over evolutionary time. And you might wonder, why does a neuroscientist even care about AI? The reason for this really comes down to this quote from Richard Feynman, who said, "What I cannot create, I do not understand." Because if we as scientists truly think we can understand how the mind and brain works, we should then be able to also build it, because that's a true test of understanding. And so in my lab, we use AI like a model organism to test our theories about the mind and brain. If we have a hypothesis that something is important for intelligence to arise, we build it into these models and see if it then develops those abilities. And then inversely, we can use our understanding of the mind and brain to also improve AI. And this relationship between cognitive neuroscientists and AI actually has a very long history. In fact, I would argue that psychologists were the ones that invented modern AI. So you can see this paper from 1958 in the journal Psychological Review, which is one of the oldest peer-reviewed psychology journals, proposed the same architecture that we still use for image and video generation today. And this other paper from 1986 proposed the exact learning algorithm that is still used by LLMs like ChatGPT, Claude, and nearly every other model in existence. And this was developed by David Rumelhart, who was one of the founders of the Cognitive Science Society, and Jeffrey Hinton, who's often considered the godfather of AI and even won the Nobel Prize for it. And so cognitive scientists have a very long history with AI, which makes intuitive sense, because if you want to build a mind, you should talk to the people who study how the mind works. And so with that, let me give you a little bit of an outline for today. First, I'll show you that AI models actually can think like humans do, but ultimately they don't. And then I'll close with a few things that we can possibly do about this. So let's start with this first piece, that AI models actually are capable of thinking like humans. And the basic principle here is that as AI behavior becomes more human-like, their internal structure self-organizes to become more brain-like. So to break this down, I first need to give you just a quick neuroscience lesson. So here we have a brain. This brain is inflated somewhat, so you can see more of the anatomy, which is why it maybe looks a little funny. But the first thing we know about brains is that we can segment them into distinct areas that each have their own function. For example, there are areas of the brain for perceiving and interacting with the world, things like vision, hearing, movement, and so on. And we might label these functions as being concrete because they deal with concrete things in the physical world. But then we have other areas that are involved in abstract processes, things like intuitive reasoning, planning, and conceptual knowledge. And we might label these as abstract. And each of these areas is comprised of millions of cells called neurons that perform the computations that make all of cognition possible. And what you might already notice is that there's this steady progression from areas with concrete functions to areas with more abstract functions. For example, visual areas moving into concept areas. And so this is a principle known as a hierarchical organization. And if we zoom into areas along this hierarchy, what we'll see is that the information content becomes increasingly more abstract. Let me show you what this earliest area here in primary visual cortex does. So you're going to have to listen here. So what you're hearing is an individual neuron firing. So every click is that neuron firing. And what you're seeing is researchers presenting a white line at a very specific spot that denotes where that neuron fires. So you can see this neuron only fires when that white line is in that spot and stops firing the moment it leaves that spot, right? So it has a very selective point in space that it cares about. See how it stops firing as soon as you move off just a little bit. And again, this neuron is very selective. It doesn't care about any stimulus. It doesn't care about if you move the line across in other angles. It very precisely cares about that line at about 45-degree angle and about a 45-degree angle in that exact spot. Again, it's not even just any line. It only seems to care about white lines. It doesn't seem to care about black lines in that exact position. So the neurons in this very first area, we can describe as representing really simple visual features like oriented lines, which are in some ways the building blocks of our visual world because they denote the edges of things. As we move up the visual hierarchy, the neural representations, basically what those neurons care about, becomes increasingly more sophisticated. Those lines combine to make more complex patterns like edges, corners, shapes. Those patterns combine to make objects and complete 3D shapes. And from there, it becomes even more abstract. Let me show you another example. So listen here again. What you're hearing is the response of a neuron in a high-level visual area. And it should be pretty easy to figure out what this neuron cares about. This is what we might call a face-selective neuron. So as we go up higher, we get neurons that are selected for real-world categories, things like faces, objects, and so on. And then once we get all the way to the end here, we might get something that we call like a concept cell. So this is a neuron that specifically cares about Jackie Chan and nothing else. So you can see this neuron responds to different images of Jackie Chan, in response to reading the word Jackie Chan, and it responds to hearing the name Jackie Chan, but doesn't seem to respond to this other guy who I think is like an Italian soccer player. And so this is the large-scale organization of the brain and the visual system specifically, where you get these increasingly more complex building blocks that start very simple and build to something more sophisticated, like the concept of Jackie Chan. And what's interesting is that when we train AI models to do tasks that are important for humans, they spontaneously develop this kind of organization. So here's a typical AI model architecture. This architecture is comprised of multiple layers, which we can think of like individual brain areas. And each layer is comprised of thousands of units, which are also sometimes even called neurons. And these are the things that perform the computations underlying AI. And when we give this model a learning objective, like telling us what it sees, the units of this model will spontaneously develop hierarchical representations. Early layers will show orientation selectivity, like those neurons I showed you in V1, where it's sensitive to lines of different kinds of orientation, sometimes black, sometimes white, so on and so forth. And as we move up the hierarchy, those representations become increasingly more complex, such that you get these complex patterns and features and shapes. You might be able to start seeing a dog's nose here or parts of a house. And then all the way at the top here, we get whole natural kind of categories: houses, dogs, cars, and so on. And just to be clear, engineers didn't design the models to have these features. This is simply what the models learn in the process of learning to accomplish this task. So in the process of learning to see, it develops these brain-like representations. And what's more interesting is that we can directly align brain neurons to model units. For example, say we show a bunch of images to both people and models, and then record the activity from both neurons and model units. And then we can just simply correlate these two responses with each other. What we see is that the models with the most human-like behavior also show the strongest correlation to the brain. So here what I'm showing you is visual perception performance of the model on the x-axis and its neurosimilarity on the y-axis. So you can see that the model with the best visual perception performance is also the one with the highest correlation to the brain. And this is pretty remarkable because again, there's no reason AI models need to develop brain-like representations. Again, this wasn't built into the model, but by the very nature of needing to solve a similar task as humans, models spontaneously develop these representations. Almost like these tasks put a evolutionary pressure, then still similar representations of models. And what I think is even crazier about this is that we can even use this principle to control the response of brain neurons. For example, we can synthesize images that maximize the responses of units in AI models. So these are some of the images that become synthesized. So again, these are images that make AI models respond very strongly. And then we can show the stimuli back to participants and measure their neural response. And so if we measure the response of the models and neurons, different images, we can see that they're pretty tightly correlated. The images that elicit the strongest response in models also elicit the strongest response in neurons. So this particular neuron seems to really care about this corner of a weight for whatever reason. But now if we show those synthetic stimuli that we developed using the models, we can now drive that neuron's response way higher than any natural stimulus previously did. Basically, no natural stimulus that we were able to show this organism, in this case, a monkey, show this monkey could drive this neuron as high as we could drive it with stimuli generated from an AI. And so this shows that models really can respond like brain neurons, just such that we can even use them to predict how brain neurons will respond in the future. And neuroscientists have scaled this principle up to basically create AI model leaderboards that try to discover the most brain-like models of things like vision, language, and so on. So the goal here is really to simulate the brain. And so together, this shows that AI models have the capacity to think like humans do, such that the more human-like their behavior becomes, the more brain-like their structure is. But even though models have this capacity, they ultimately don't think like humans do. And the reason we know this is that AI models make errors that no human would. For example, if you take an image and apply just a very simple distortion to it that changes the statistical properties of an image, and it's even hard for us to see it, you can get models to say that this baseball is now a green lizard with almost 90% confidence. Or that this cat, which we've applied this funny texture to, is now far more likely to be an elephant than a cat. And we know that these models have very little common sense. For example, some of you have probably seen this car wash example floating around, where if you ask ChatGPT whether you should walk or drive to a car wash, it will miss the point entirely and tell you to walk. And this is why these models make these kinds of funny errors, right? The models understand the associations between things, but can't actually put them together. And we as researchers understand why these errors are happening. AI models are just stochastic prediction machines. They try to weight their inputs to predict the most likely outputs, but real reasoning is often is more than just simple association between things. And what's most problematic about this process is that AI models need a lot more training than humans do. So this is actually something that we've been focusing on in my lab. And we started this endeavor with a process that we generally think AI models have gotten pretty good at. And that's visual recognition. So the ability to say what you're looking at. For example, if we give participants and models this task, where they're shown this stimulus very quickly, and then they have to say whether they saw an airplane or a truck. And so here we tested children, adults, and AI models on this relatively simple task. This task could move pretty quickly, so stimuli are presented as fast as a tenth of a second, and the images could be distorted in a number of ways. So let me show you what this looked like in practice. So it is a little tough. You might not be sure whether a 3-year-old could do this or not. All right. So if we take a look at the results, First, what I'm showing you is the performance of many kind of AI models as a function of how much experience they've had, basically how many images they're trained with. And what you can see is they show this very predictable pattern performance, such that models that have received more training generally do better than models that have had less training, right? This is a very standard scaling law of machine learning. And so we might ask, where would humans be on this plot? Now, it's a little hard to compare model experience to human experience, because what does 10 billion images mean on the scale of a human lifespan? To give you a better sense of these numbers, imagine if, from the moment of birth, a child were to see a new image every 100 milliseconds of their life without ever sleeping. That's a new image every 10th of a second, nonstop, without sleep. They would still not see as many images as a clip model, this model all the way here in the corner, until they're nearly 40 years old. These models have had an immense amount of experience. And so when we plot human data using this metric, we see that their performance is generally above and to the left of the line. 4 and 5-year-olds are already doing pretty as well as some of the best models out there with hundreds of times less experience than these models. And the 3-year-olds are not that far behind. And you can see that the models that actually have comparable experience to humans are only barely above chance. And so this suggests that humans are far more efficient than current AI models and can form visual concepts with much less experience. And this isn't just something about visual tasks. The same is actually true for language models. So here I'm showing you how many words humans are exposed to across their lifespan and compared to what are now some older large language models, some LLMs. And even with these older models, it would take about 1,200 years for a human to be exposed to as many words as these models are trained with. So again, these models get massive amounts of experience. And these inefficiencies in models have real world consequences, because such inefficient training comes with massive energy and climate costs. Training a single large language model emits much more CO2 than the entire production and lifetime use of a typical US car, and many more times than an American adult uses in a single year. And these energy needs are just getting bigger and bigger as AI becomes more ubiquitous, such that collectively AI data centers use about as much electricity as the entirety of Russia. And this is now a few years ago, so this estimate has gone up since then. And just to give you a comparison here, the human brain runs on just 20 watts of energy, which is about as much as a light bulb. And even though AI models have the capacity for human-like reasoning, current models are clearly not yet human-like. They require far more experience than any human can possibly acquire and still make errors that no child would. And so what do we do about this? Perhaps you can already predict what I'm going to say, but one thing we can do is simply develop AI models like humans develop. That is, to make AI models more childish. And the idea here is that immaturity early in development is adaptive. The humans start small and master simple processes before moving on to complex ones. And by contrast, current AI are often trained to do some complex adult task right from the outset. So what we can do is take principles from how human intelligence developed and implement them into AI models. So this includes things like how the human brain architecture develops. I've been showing you this image here of how concrete to abstract processes are organized in the brain, but this is also the developmental trajectory of the brain where those concrete regions develop earlier than those abstract ones. And we can think about training AI models in a similar way, in a similar hierarchical way. Human vision and sensory perception is also not perfect from the outset, such that infant vision, for example, starts blurry and becomes progressively more clear. And our experiences also become increasingly more complex as we age, such that infants initially only look at simple scenes and progressively move on to looking at complex ones. And finally, the learning objective of humans is fundamentally open-ended. Children are not trained to do a specific task, but learn a foundation model of the world by following what's most rewarding for them, essentially curiosity-driven learning. And implementing these processes into models really does make a difference in how AI models learn. For example, training models on this blurry to clear sequence improves their robustness to adversarial images. For example, if you train a model like an infant experiences the world going from blurry to clear, they now exhibit better performance on those challenging examples I showed you earlier. And from an engineering perspective, this is perhaps unintuitive because as an engineer, why would you feed your model lower resolution data when you have high resolution data available? But this kind of developmental progression is actually adaptive to wiring up the human system. And similarly, AI models learn better and faster when they're trained with childlike experiences. For example, what this graph shows is the progression of model learning across different stages. So these blue bars are models trained with a developmental sequence of experiences. So learning on data from 2-month-olds and 6-month-olds and 12-month-olds and so on. And the other colors are different kinds of training, other kinds of training sequences. What you can see is that models trained on the developmental sequence outperform almost every other model, even after this first stage of training. And so it's not an accident that humans go through this developmental sequence. It actually optimizes how we learn. And so these are just some quick examples about how principles from child development can be used to improve the performance and efficiency of AI models. But it's important to remember that this whole process of childhood exists in the first place to make humans domain general problem solvers. And what that means is that the principles of child development really apply to any domain. We can think about, for example, the child's architecture as building complexity from smaller reusable pieces, our inputs and experiences as us naturally constraining the problem space and progressively adding complexity. And even curiosity-driven learning is really just a way of saying to work on things that are actually rewarding, to follow where the rewards are. And just like Da Vinci's idea of taking inspiration from nature, learning from childhood is really a principle that we can apply to across many disciplines and across many different kinds of problems. And so with that, I'd like to thank my many collaborators at my lab, and of course, Chris and Eve for facilitating this. Thank you, guys.
Vlad, thank you so much. My goodness, there's so many things to unpack in there, but wow, so interesting to consider. One of my many curiosities that this has flagged for me is what happens in general, right, as humans, or when we think about intelligence, when we skip developmental stages within ourselves. What kind of warning or flag does that elicit to think about, even as humans, when we skip and try to circumvent any developmental stage, we end up facing it eventually. We end up having to confront it.
Yeah.
And so
Yeah.
this reminds me very much of that, right? It's if AI is trying to skip being a child, it eventually will have to, if it's going to sustain,
Yeah, it's going to have to reckon with it.
yeah, what we define as intelligence. And then also it arises the question for me, do we even want it to be that close to human intelligence? Do we want it to be something entirely different? So these are just a few of my curiosities, and I only share them as much as to start to give fuel to fodder to your own thinking here about what brings curiosity to you about some of these thought bubbles that arise as Vlad talks, and or what questions do you have for Vlad? I'd love to open up the floor both to questions and if you have a curiosity that's arising for you as a flag here as you think about your own relationship to intelligence and AI.
Yeah. And I guess I'll start just by answering or addressing some of the points you raised, which I think are really important to think about. And so there's this question of what happens when we skip important developmental milestones, and also what happens when we introduce them too early, because those are actually really complementary challenges. And we know from the neuroscience literature that when we have different kinds of deprivation, for example, children that are born with cataracts that don't get removed till much later, basically go from no vision to a very clear vision, but it's almost too late. Their visual system is just dramatically impaired and they never fully recover. And inversely, if you provide too much stimulation early on, for example, preterm infants that have left the womb and are now in a very busy, bright NICU, their auditory cortex doesn't develop the same way that even the same preterm infants in a quieter space develop, right? So both deprivation and too much stimulation early on are both problematic. And so it really speaks to this idea that humans have developed this, that the developmental sequence is really adaptive.
Yeah, really interesting.
There's a lot in it.
Both going forward too fast and backwards. Fast.
Yeah, there's a Goldilocks zone of
Yeah.
development.
Maybe there is something to parents' preoccupation with not exposing their children to things so early. What sometimes seems like hysteria, like maybe there is some actual wisdom to that.
Screens are definitely could be considered a form of input that, that's much faster than the natural world, much brighter, changes much faster. And we can think about that as a form of literally overstimulation that the developing brain isn't quite ready for.
And it's similar to the image you had where the AI had designed images that would activate certain neurons, right? Like a child having these YouTube channels that are malicious in how well they are to capture the child's attention and keep them watching.
Yeah, or social media. I also want to
Yeah.
get from other people, and I'm sure other people. Does anyone? We're such a lovely, sweet group here. Does anyone who just wants to ask a question or raise part of something they're thinking about, please go ahead. Either raise your hand and I can unmute, or just unmute yourself, and that's great.
You can do. Share on behalf of Clarissa, who's on the road, but she said it's crazy how some shows make her daughter psychotic and others make her totally chill. Yeah.
Absolutely. BB, you're raising your hand. Go for it.
Yes. Hi, friend. So many good friends in this call. Lovely to see everybody. And thank you guys for this talk, because I feel like these talks really, to give props to Vlad and all his work, it fires all of our cylinders. So I've been very curious about the work that Google DeepMind has been doing regarding artificial intelligence. And I think I mentioned it to Chris when I saw the flyer, but if you guys haven't seen The Thinking Game, which is a documentary about Google DeepMind, and Demis Hassabis is pretty big in it. It's really, I found it to be quite heartwarming, as much as artificial intelligence could be heartwarming, because of the way that the process was approached by DeepMind, and also because of the way they're orienting it towards medical research, getting the Nobel Prize, etc. I wanted to share more than I have a question, but I also wanted to share. I'll drop the paper in the chat. Is a paper where Google DeepMind is looking at measuring progress towards agentic artificial intelligence, like really developing a cognitive framework, basically, and trying to figure out if there are ways to measure whether or not AI is being intelligent or not. And they did 12 categories to save everybody a bit of the read. And then they're doing a hackathon to bring the brightest minds together to figure out how to measure the hardest 5 to measure. Because there's a lot of artificial intelligence is impacting us, we're impacting it, we're learning from it, it's learning from us. And so there's all this thought about, oh my God, what's that intelligence? Of course, they cannot walk or drive to the car wash yet, but there's a lot. And when I finally get myself to San Francisco, I'll share a lot with you guys. But Vlad, I want to know, what do you make of all of this process that is now starting, where people are being paid an hourly wage to do manual tasks with a camera affixed to their forehead so that robots can be taught factory floor work, et cetera, et cetera. Like it's accelerating to a point of you teach one, you teach a million. I also have a couple of podcasts to share, because this conversation has been brought out a lot. There's a lot of research in Boston Dynamics, and I don't even want to know what they're doing in China. Right? What do we think about these things, which are like, God?
Yeah. I'll say the first thing, the article you sent, the senior authors there are psychologists. So Matthew Botnick and Noah Goodman are psychologists. So they very much know this research, and I actually worked with Matthew Botnick's advisor at CMU. So Google understands, Google Meta, they know who they're hiring to run these labs, right? It's not an accident that these are cognitive scientists and neuroscientists. And they are probably thinking about these issues not so dissimilarly to how I am and how my lab thinks this. So to speak to your other point about what do we do with all this potential automation, I don't have a good answer, because I think like the Industrial Revolution that disrupted things for a lot of people for a long time, something similar could very reasonably happen to us. And it just won't be limited to just blue collar jobs, because a lot of the jobs that are getting automated first are cognitive jobs, white collar jobs, right? Writing, coding, et cetera. The jobs that are actually going to be safest for the longest are probably skill labor. So it's very hard to get a robot to be a plumber. Just the task, just the motor coordination, just every bathroom is different, just everything that needs to go in there to reason about that new situation is actually far more complex than what we typically thought about as high skill work. And it's actually going to take much longer to automate someone being able to come into your home, figure out what's wrong with your particular kitchen or bathroom. Personally, I think I think addressing that is going to be more on the policy side and us being very intentional about how we smooth this transition. Because even with the Industrial Revolution, we came to some new equilibrium where it opened the door for new kinds of jobs, right? But that transition is still painful for many people. And I think there has to be a lot of intention in how that transition happens so that it doesn't just disrupt life for millions of people. But I have some views on what that could look like, but I'm certainly not the expert
Yeah.
on that.
But can we teach them by virtue of showing? Can they, obviously it's not embodied knowledge, but we are giving it POV
Yeah.
knowledge. If you put a camera
Yeah.
to your eyes and you're putting up a
Yeah.
painting, cleaning a floor.
I will say so. So it ultimately, yes, with enough data, we can get them to do anything, but this is kind of brute forcing it, right?
Mhm.
It's if I give you every possible example, every possible case where this happens, you will be able to learn almost all those cases and generalize a little bit. What humans do is obviously we don't need to see every warehouse in the world and every box in every position to know what to do with it, right? The plumber doesn't need to see every bathroom. But with enough data, like Claude and ChatGPT, they're not really generalizing anymore. They've just consumed enough data that something like what they spit back at you is common and is in there somewhere. And that's why these car wash examples happen, is those are the exception of when you're asking this distance metric is the exception, not the rule, right? Typically when you're saying, do I walk or drive? It goes, oh, it's this many miles or whatever. So you drive or you walk. But now you have
Claude
this
usually
new
asks you,
twist. You have this new twist on this being like, here's a specific context where you're doing the opposite, which is just less rare in the training data.
Super.
Yeah.
I would love to hear. I think both Church, Lewis, and Jasmine have things to say. So I cannot wait to hear. But Dad, you put yourself off mute, so go for it.
No, I think this is absolutely fascinating. I thank you so much for organizing this, and Vlad, thank you for your insights. I had a chance to meet you in person, and that was
Yeah, no, it's good seeing
a pleasure. I think as we all in our lives come to terms with AI and what it means for our work and what it means for us personally, yet I have a lot of optimism and a lot of fears. This context is really interesting. I'll give you an example of one of the things that made me optimistic, which is not Chris, but another son-in-law, Alex, and I were having a conversation, and I was bringing up information, and he was like, no, that can't be right. That can't be right. And since he's like digitally native as somebody over the age of 10 can be, he immediately asked Claude, so this is like Wikipedia on steroids, because Claude immediately within seconds, gave a pretty comprehensive answer on a fairly complex topic. That enriched the conversation for sure. Oh, I never knew that, or I'm just amazed by that, right? I had no idea.
Wrong, though. That's important to remember. Sometimes the thing.
No, it can hallucinate. I'm not trying to. This is just part one of the narrative. There are obviously huge downsides here, and one of the downsides, driving last night, listening to NPR, is this whole cybersecurity issue, which is the assessment, which is probably correct, is that AI is going to be able to hack anything almost within a month. And there's nothing that can be done about it. And somebody was saying, hasn't somebody considered maybe just not making this capability available to the world? Has somebody considered that? The person said, that's a great question. Cat is already out of the bag. I'm afraid that train has left the station, and we're going to face massive disruptions even to this fraught digital world that we live in because it can be blown up easily and instantaneously by some evildoer in the middle of some part of the world that we're not connected to. I think this kind of issues about how AI could be made more human-like is really interesting as one takeaway from what you presented. Another takeaway is it can never be as good as humans. So how do we learn about what's really special about humans and preserve ourselves from a completely digital takeover? Those are just some thoughts. I'm just rambling, so I'm not sure there's any that can be
What
responded.
I really like about what you share, and I've been thinking about actually, I don't know, maybe for arguably for years, is how potentially in the face of AI, and actually we went to a recent dinner around AI, and it was everyone's conclusion was like potentially in the face of what is not human about it, we may come to appreciate what is human about, deeply human about ourselves. And that could be really positive. It's sometimes we don't see something until it's mirrored back to us in the converse of what it is. And part of what you're saying, Vlad, is even in studying these models, we may come to realize actually how beautiful intelligence or human intelligence is. And of course, it can teach us something, right, about what AI could be, but it also reminds us of who we already are, which arguably is just as beautiful of an endeavor as discovering what more AI could be as well. So, definitely, if nothing else, just a poetic reflection on humanism. But Jasmine, I know that you're about to teach very relevant course to all of this and probably have lots of thoughts and or a question. I'm not sure, but I'm excited to hear your voice.
First of all, thank you guys so much for doing this. Thank you, Vlad. Thank you, Chris. Thank you, Eve. This is so cool and so interesting. I just have a question for you, and maybe this isn't like it's adjacent maybe to your work or like labs that you know it, but I'm what makes me most like worried are the centers that are being set up all over rural areas and cities all over the world because actually of the noise output. So the vibration and the noise is disrupting nature's patterns. And when nature's patterns are disrupted, our own physical health patterns are disrupted. So there you go. Neurology, development, like all the things you're talking about. I would love to hear from you. Is there anything you guys are like directly looking at there? Because it would seem to me this is such a like generative, interesting, futuristic thing. And then we have these like mega archaic data centers that are like
Yeah.
really terrifying.
Yeah.
And yeah.
Especially in how fast they've just come up everywhere.
Yeah. And I own land. I got offered a deal to buy my land for something that was very vague that I found out was actually for AI and development and all this. So they're buying land everywhere, particularly BlackRock and these larger financial institutions tied to the growth of OpenAI, particularly. Anyways, it's all really deep and dark and intense. But
Yeah.
a human development standpoint, I think of Chris and Eve having a brand new little one, right? And the sensitivity of their little baby next to a data center, right? And how that could, and that's the kind of stuff it's hard for me to actually get into the conversation of AI seems amazing. It has amazing capabilities, but if it's going to then destroy all of these cyclical rhythms that are like interconnected to our aliveness, what are we doing here?
Yeah. Then there's a couple intersecting issues there, right? The first is that most related to what I was talking about is that because these things are just so inefficient, they're just the only way of training them is just brute forcing on all the data in the world. You need massive data centers, which are consuming massive energy, et cetera,
all
et
this
cetera.
like bloat. It's like AI bloat.
Yeah, that's right. But because that's right now is the only way they knew how to do it. There's a saying, scale is all you need. And so that directly contributes to needing these data centers because they're so inefficient.
Yeah.
The second piece of that is we have not made particularly remarkable progress, or I should rephrase that. We actually have made pretty remarkable progress on energy output and greener energy. We just haven't implemented it in a standardized way. And there's all sorts of proposals about sending AI data centers to space, burying them in deserts.
Right.
But to Church's earlier point, like we haven't stopped to ask the question why. The assumption is that others will get further ahead. China is doing it, thus we must.
Yep.
Really good article in Atlas magazine that I'll share with everyone after this, which is Alta magazine, which is a California magazine, where the guy asked that question. Where he's like, people think of socialism, communism, and capitalism on different spectra, and he's like, oh no, these are the same thing. They're both proposing more
Yeah.
technological fixes to the technological problem. And he asked the same question Church did. He's like, what if we just didn't do more?
Well,
What if we did
well,
less?
Yeah, so this is my other point is it has not been as straightforward as I think a lot of these companies thought to actually monetize this. And so there's actually been there's a lot of speculation and a lot of people thinking lots of cool demos, so many amazing demos, right? But actually making money off that has not been as straightforward. And so some of the growth has already started to slow. And some of the big companies, OpenAI, Anthropic, et cetera, have actually realized, okay, we've been held up on all the speculation, but now we're not actually getting the return we need to keep, because it's so much money and so much energy to keep these data centers running. And the return on this actually hasn't fully come through. Maybe it will in the future, but at this point, it's not 100% clear whether we actually do need this for everything it can do.
It reminds me of that Nikolai Tesla moment. It's like we had a moment in history where we had the option to move forward with smarter options, and we would all be in like really different places had we used energy differently, right?
Yeah.
So is Church, you bring up a really important point that keeps coming back to me is there's no regulatory things, there's no governance, there's no the why of do we need this? How do we need this? How is this actually helping us? How is this actually helping future generations? Those humans that are babies right now that we need to look after, that we need to nurture their future. This is the big real hole in all of this because we've gotten so obsessed with money only and the idea of money. It's to your point, Vlad, it's a lot of the ideas of what's profitable versus what it actually is. So thank you again, all of you. It's really been
Oh, meaningful, Jasmine. Thank
Yeah.
you so much for bringing that up. I really also like a lot of, I said it, I think before you joined, but like thinking of the rewild is also rewilding the body. Like, how do we
Right.
come back to that's at least an interesting exploration for me in all of this.
Totally.
I think a lot of we don't realize how much of the body actually does intersect the systems that we have and are impacted even in the what we consider to be in the background of everything. But Vlad, on this point, I'd be interested to hear from you from your research. The part that brings up for me is that you are saying like, okay, if we applied this way of learning to these AI models, they would be more energy efficient. And so to Jasmine's point, I assume, but I also don't want to assume that's not that fast. That would take a lot of time and over time of doing that and making that decision for then those AI models to not be taking up the energy that they're taking up now and causing what Jasmine's saying they're causing. But maybe I'm wrong. Do you have an idea of, let's say, in an ideal world, we did apply this way of developing intelligence to all AI models, what would we be looking at? Could there be policy created where that says we have to have AI models learn this way? Because it's not realistic to say we won't have any AI models. No one's going to say yes to that, but they may say yes to, okay, there's policy to be applied here where AI models could learn more like children. And
Yeah.
if they did, they'd be more energy efficient. But would that even make sense? Could that have a good impact or dearth on
Yeah.
from
I actually think that this is one of those areas that won't need policy change because it'll just work better. It's just so expensive to train AI models the way that we're currently training them that if you want to, like even just purely, so you want to stay ahead of the competition, you want your models to work better and you want to spend less time and money getting them there, that this will just be potentially a natural path forward that people will take. And there are already
just because they don't know.
part of it, yeah. Engineers are not the most knowledgeable in child development. And it's a slow process, right? People started with, let me try to make it like an adult. So I'm just going to try to copy what an adult can do. Okay, I'm getting 40% there, 50% there, whatever. What am I still missing? And there's a little bit of a scientific process of you're trying to increasingly, progressively find the ingredients that are necessary to develop the ability. The field has made this very fast, sudden jump, right? Where we had no AI, then 2014, 2015 comes around, and suddenly we have these models doing really amazing things. And people have been following that same path, but that path has now hit a plateau, both on the neuroscience side and on the engineering side, where the only way we know how to make these things better is by just scale. And that obviously, the challenging thing is that it works, but it comes with all these other costs.
Yeah.
And so a solution that has already been used in the engineering side is to create what are known as foundation models. Basically, you train one big model, like a Claude, let's say, right? But then that model's training can just be used as a foundation for lots of other tasks. So you don't have to keep retraining new models. You just take that as the foundation, and it can already be close enough on lots of other tasks, and you just fine tune it a little bit to make it better for your specific case. That's already a lot more efficient, because instead of us each training our own big model, right, on each of our separate tasks, and we train one shared one that uses a lot of energy, but then we reuse it, right? And that's the same principle here. And that's what this is almost proposing a more efficient, more biologically plausible way of creating that foundation.
Cool. Very interesting.
One thing,
One thing, sorry, Church, one moment. I just want to be mindful both of people's time, but also we haven't heard from 3 other lovely individuals. You absolutely do not need to say anything whatsoever, but I do want to leave space in case there was something you did have a question. And I know some of us can be very eager to talk, me included. So if there is anything that you want to say or share, we'd love to hear from you.
Yeah, I think we were getting close to a big question I had without like actually diving in. And I think I know the answer. I just want to bring it up. And that's the issue of, okay, AI can learn like humans. AI does not learn like humans. And here's how we get there. But instead, we didn't back up and say, why did we end up with these models that don't learn like humans? I think the answer is maximizing shareholder value for this quarter, because that seems to be the answer to a lot of our questions. But I guess I'm coming from like B2B tech marketing. I'm working with these AI products that are already like ready for market, but I don't know a lot of the history behind how these models were developed. And I'm seeing a lot of what you mentioned as well, Vlad, is the appetite isn't there for AI infused into everything. I think about what we've been seeing with Copilot lately and how like it's just being shoved down people's throat and no one wants it. And Claude's at least, or I guess Anthropic at least has a better marketing game going on here. There's still a lot of, I'd say we saw some backlash with the Super Bowl ads and all that, really the spectacle of it all. But I think what we saw at the Super Bowl is something that a lot of knowledge workers have been feeling for a while. And a lot of the general public just hasn't cared about AI as much, except as this abstract fear or this abstract, or I guess not abstract, but as a toy. But yeah, I guess my questions and thoughts are around like the business case here, because I think if the case is, as you said, like we'll get to a point hopefully soon where it makes more business sense to train models this way. But all the time and resources that have been, I wouldn't necessarily say wasted, but all the time, but it's hard to tell because scale obscures a lot of the waste. And that's part of the problem too. But I definitely think that's the way forward, especially when there's no appetite for any regulatory intervention at all. The business case has to be made that this is the better way forward. And there's some very real resource constraints there too.
And I actually just want to highlight something that's related to something Church said. I think unlike a lot of technologies over history or weapons, whatever resources, AI models are actually something that are accessible at a smaller scale. in a way that can compete with Meta and right? I can train a model in my lab with a relatively small amount of money, and I can have it do pretty well. And I can show that, hey, look, I just did this thing. It's better than Claude. And that is a democratization of the technology in a way that the Industrial Revolution doesn't allow, or arms races don't allow, that even if you have the mega Facebook, Google models, you act like an individual actually can compete in a way has not been possible. That's not directly related to your question, but it's just something that I think is also important to raise here. And I don't want to say that this process that people are taking hasn't worked, because for a long time, before us, about like 2014, 2015, psychologists, neuroscientists were trying to make models by like carefully following human biological principles, and it just wasn't working. And so what actually did take a little bit of just saying, hey, we finally have the GPUs and the scale of data to make this work to some extent. And now we've hit that. Now we're starting to hit that wall. But actually going that first science bottom up way wasn't working and then the scale approach was, and now we're realizing we probably need a little both.
And just to
So what you're saying is we have the technological resources with the GPUs and processing units and all that good stuff.
Right. It's still not as efficient as human, but we have enough scale to make that work. Yeah. And that was really the advance in 2014, is that they trained a neural net has been around. I showed you guys for ages now. The technology itself is not actually new. What was new is Jeffrey Hinton put it on a GPU and trained it on a big data set in only a month at the time versus what would have otherwise taken many years.
And just to add one thought, the financial aspect of like scale is obscuring this inefficiency. It eventually does catch up with that. We saw with Sora got closed after 1 year, right? That was a huge attempt, big push. And they thought we are going to crush the video industry, and it could only have been launched by people with no experience of video.
And so training Sora models, those kinds of models are the worst insofar as the inefficiency. Like text is, yeah.
But I also, there's Jimena. I also really want to hear from
Yes.
It's such a gorgeous human.
Yeah, great conversation.
You're here.
Yes, and I see you both and Chris, everyone.
And then Jimena, I'll facilitate a little because we are going over, but this is just so amazing. So anyone who can stay, thank you. Please stay. Jimena, we'll hear from you. Church, I know you had a thought, and then BB, you'll close it out. All right. Okay. Go.
Okay. I am interested in the dimension of AI ethics and responsible AI, and it's very interesting the approach you're suggesting on childhood development and this human biological understanding in order to make more efficient the learning process for these AI models. From an AI ethical perspective and responsible AI, I was wondering, like, would that mean that we could also have an opportunity here to embed, strengthen more responsible ethical behavior in the AI models? Is that a possibility there? Or is that question is for another different domain? Like, how do you see that?
Yeah. So it's outside of what I work on, but there are certainly groups in my space looking at moral AI and how do humans develop morals, right? To what extent do babies already have some sense of right and wrong? And there's a very rich research program that infants prefer helpers over hinderers pretty early in development. And what does it take to develop those sort of proto-moral senses and cultivate them? And so there's also like a basically computational social cognition side that is very much thinking about this, not directly in a learning sense like I am, but in what does it take how do humans interact with each other? How do we function in a group, in a society with others? And how do we also model? So this is certainly like again, I'm less knowledgeable in this space, but it's certainly a very rich area of work that a lot of very smart people are thinking.
Thank you for bringing that up, because I actually didn't even think about that really. I've thought about ethics, obviously, but in terms of what you're bringing up, Vlad, which is just so interesting about, right? Like already what kind of ethical behaviors are built into a child, or like ideas of morals are already built into how we learn. It might be just like also another layer, another good a positive layer on if we did train
Yeah.
models like this, like how might their ethics unfold as well as their efficiencies. Ethics
Yeah.
and efficiencies in AI.
Yeah.
Is our next talk, Vlad.
And it's up to us, right? How far down this rabbit hole do we want to go? I gave a few examples that are mostly in the domain of vision because that's where I work, blurry vision, whatever. But the developmental psychology is much broader than that. And just, it's really up to us to decide what we value and how much we want to implement here. It's not an inherent constraint.
So
Cool.
interesting to think about. Thanks, Jimena. That's a really good point.
Thank you.
Church, did you have something you wanted to say? I think now it might be back a few layers, but I want to hear from you.
I put it in chat. and
Okay.
It's really just responding to Jasmine's question about society's responsibility vis-a-vis AI and why are we just completely free form, and the libertarian view of just let it do whatever it's going to do, and that's better than trying society or government or anybody trying to do anything, which I think is completely wrong personally. But Chris recommended the book, which by Yuval Noah Harari, Nexus, which was awesome on this topic. So I just wanted to bring that up for people who are interested in that topic about how society should think about AI and responsibility in terms of making decisions about AI. So that was one thought. Lena, anything you want to say? I'm here with my partner.
I've been thinking about this as I listen to people speak from the point of view of we didn't grow up with AI, or at least my generation, as part of our learning curve every day. There was no Claude, there was no Chat GPT. And our children are going to be in a place, and our grandchildren, where this is going to impact absolutely their lives. And you begin to think, when do they lose some of their learning curve on their own beings because of this bridge always into the written word and the concepts that are brought to them? Their curiosity has to have an impact on them, one way or the other. And from the point of view of watching kids look at art, which I did for 20 years from second grade through college, this really does have an impact on how to translate that to a given task that an AI something would want to convey. I don't know how they.
Yeah.
Yeah.
Reminds me of my first curiosity of, right, when we skip, whether you call it skip developmental steps, or when we reach obsolescence in a certain area, like what happens essentially, like what atrophies or what shifts or what different kind of skills do we learn. It's really interesting from a learning perspective, Vlad, I'm sure, like what is lost, what is gained, and just what is different.
Yeah, no, it's something I actually so understandably end up teaching a lot of AI stuff in my cognitive neuroscience class to my undergrads. And I talk to them about this, right? I don't know how to teach you to write anymore, because writing, you have to write badly for some number of years before you learn to write well. And with an AI model, you can now write mediocrely right away, right? And so it's like a development process. You skip the sequence of being bad at something to get really good at something to just be mediocre.
Do you ever, arguably, then do you just mediocre? Do you not
Right.
improve?
Yeah.
What's the trajectory on learning in terms of
Yeah.
improving that skill or crafting that skill, or even the desire, right? Like then it intersects not just with curiosity, but the impact of desire or motivation in learning as well. Okay, we're definitely going over. BB, can you close this out? Just any immediate final
thought.
And then I just want
A
to
thought.
and then we have to say goodbye to everybody. But BB.
Yes. This is so lovely. I cannot wait for the next one. I was just going to say, to the point of you would stay in mediocrity versus spending time building a skill. I think that in that case, human nature will reveal itself, and people who want to excel will drive to excel, now supercharged with tools that can get them further faster. And people who settle, and because that's their process and that's where the journey leads them, they will settle and they will feel like they're doing their very best. And all the best to everybody, because in this very uncertain moment, I feel like everybody's trying to do the best with the tools at hand, with their curiosity, their livelihoods, their ability to understand. So I have a lot of respect and love for this moment that is pushing us all to the edges of our own imagination. So thank you for hosting this.
Thank you,
Thank you,
everybody.
Bibi. That was great.
Bibi, I
Thanks,
couldn't have
Bibi.
said it better, so I'm just gonna end there. And thank you so much, everybody, for coming today. Vlad, wow, you're doing such important work. through-
Thanks,
and
guys.
Really, just so fascinating applied onto the lens of right now and our own learning, our own minds, and I'm certainly carrying it with me as I think about my own advancement in learning. Thank you, Bibi, for your rockets. And I'm wishing everybody a beautiful weekend and would love to catch up with each of you. So don't hesitate to reach out.
And would love to have a second conversation with all of you. And Vlad, I have some specific.
Dad,
But
actually,
you-
thank you so much for that. Tectonic Talks will now be a reoccurring series in relation, as I mentioned at the beginning, with the Rewild, the magazine. The next issue of the Rewild will launch in July, which will be exciting. I'll give you all a little insight. It'll be Traverse the Adverse is the issue, all about how adversity builds who we are, our resilience, but also not just who are we when we overcome, but who are we in and through the adverse moment. And certainly, I'm sure more of Vlad's work applies there, right? When adversity applied to learning builds better things, and we're no exception. So this definitely applies there. We will talk to Vlad about the potential of a follow-up talk, and other talks certainly are up and coming. So we hope to see you all there. Thank you.
Wonderful.
Thank you.
Awesome. Bye bye.
Bye-bye.
Thank
Thank
you.
you.
Thank
Bye,
you very much.
everyone.